Hello, welcome back to the Spirit of Artemis. The Artemis 2 mission is a test mission. So rather than head to the moon right away, the mission planners decided to have the Orion spacecraft orbit in a high Earth orbit for about a day before heading towards the moon. Today we're going to take a look at the orbital maneuvers that the Orion did around the Earth, and then we'll see how they headed for the moon after those maneuvers were completed. After the core stage separation, the Orion spacecraft coasted higher in altitude. And just like a baseball thrown straight up, as it coasted higher, it slowed down because of gravity. To understand what happened next, let's get some terminology down. In an orbit around the Earth, the point farthest away from the Earth is called the apogee, and the closest point of approach is called the perigee. After the SRBs and main engines had done their jobs, the apogee was pretty high, about 1,400 miles in altitude, much higher than the typical 250 miles of altitude for the ISS, for example. However, at this point in the flight, the spacecraft was still suborbital because the perigee was back in the atmosphere. So the Artemis crew had to raise the perigee, and the best place to do that was at apogee. When you fire your rocket engine at apogee, you don't waste energy making your apogee higher or lower, so the energy goes into raising the perigee. The astronauts performed this perigee raise maneuver using the ICPS engine at apogee, about 50 minutes into the flight.
You can see the perigee raise maneuver from the main engine of the ICPS firing from the solar array wing. Standing by for confirmation of cutoff.
Integrity good, PRM, and 1 minute to teeter handover.
The PRM successfully raised the perigee to a respectable 115 miles of altitude. The next step was to put the Orion spacecraft in a very high Earth orbit, with an apogee of 43,760 miles of altitude. This would allow the astronauts to have almost a full day in Earth orbit to check out all of the Orion's systems. Again, the best place to raise the apogee is at perigee. So at perigee, about an hour and 48 minutes into the flight, the interim cryogenic propulsion system engine was used for an apogee raise burn.
At this time, the flight dynamics officer confirms that it was a good burn, so they are on a good trajectory for staying in high Earth orbit for the remainder of this flight day and into next. The high Earth orbit puts them into a 43,730 by 0 statue mile orbit, which orbits the Earth approximately once a day. It's a 23.5-hour orbit.
After the apogee raise burn, the Orion spacecraft separated from the interim cryogenic propulsion stage. Pilot Victor Glover and Commander Reed Wiseman then used the ICPS as a target to practice the kind of maneuvers that will be necessary for rendezvous and docking on future flights.
Yeah, we have good separation, good motion. We are ATP go.
Confirmation, separation from the interim cryogenic propulsion stage.
Good motion. Go for 180 pitch, confirmed. Separation confirmed, Houston.
Houston copies.
All right, here comes the pitch rate.
At apogee, the Orion main engine was used in a longer perigee raise burn. This was to adjust the orbit for the best conditions for the translunar injection burn.
And that perigee raise burn is now underway. And we do have confirmation that that burn is complete. It was a good burn.
We're tracking a good burn.
The orbital maneuver that would send the astronauts on their way to their encounter with the moon was the trans-lunar injection burn.
10 seconds until translunar injection burns start.
Integrity, good engine, good control.
We show the same. Feels great up here.
At MET, mission elapsed time of 1 day, 1 hour, and 14 minutes into the Artemis 2 mission. As Orion was flying 115 statute miles above Earth and 247,600 miles away from the moon, we have the start of the translunar injection burn that will send the crew around the moon, the first humans to do so in over 50 years. Orion now 520 miles away from Earth. Just 5 minutes ago, we were only 115 miles above Earth's surface. That distance will continue to increase as we are now on a trajectory to fly around the moon for the first time in over 50 years.